Yesterday we saw about the electric field expression on the axis of a, what is that one? Charged circular loop. Now we will move into our next topic, very important. What is that one? Gauss law. Okay, see carefully. In entrance point of view, 100% one question should be there. So listen carefully, because here hypothetical will be more. So listen carefully. What is meant by Gauss law? Here Gauss law states that in any enclosed surface, the electric field, electric flux we make tell. Electric flux is equal to 1 by epsilon naught times 1 by epsilon naught times of electric charge enclosed in the surface. This is the statement of Gauss law. What is the statement? In any enclosed surface means what? The surface should have definite limits. So in any enclosed surface, the electric flux is equal to how much? 1 by epsilon naught times of the electric charge enclosed in the surface. Means what? Here suppose if you take one example, let us assume that this is one given surface. What is this one? Given surface. What is the nature of this surface? This is enclosed surface. What is that one? Enclosed surface. In that, suppose some Q charge is enclosed. That means Q charge is within the surface. Then in the vicinity of Q, if you consider a small sphere, then already we know at each and every point on the surface of the sphere, it is having, what is that one? Electric field. That means what? Electric field lines are passing. What is the direction of the electric field lines? Away from the positive charge. This is positive charge. So away from the positive charge like this. That means what? Here per unit area, what is that one? The electric field lines are passing. That is said to be what? Flux. So its flux is equal to 1 by epsilon naught times of the charge enclosed in it. That means what? Into Q. This Q we may write Q in. Q in means what? Inside of the given enclosed surface, the charge is there. So phi is equal to what? 1 by epsilon naught into Q in. Another example, if you see, suppose let us assume that this is one enclosed surface. Here Q1 charge is there, here minus Q2 charge is there, here Q3 charge is there, here Q4 charge is there, here Q5 charge is there, and here minus Q6 charge is there. Now in this, what is the flux tell? Phi is equal, what is the flux according to Gauss law? 1 by epsilon naught times of the charge enclosed in it. So 1 by epsilon naught times, here inside how many charges are there? 4. Total 6 charges are there, but inside only 4 are there. So you may write 1 by epsilon naught into what? Q1 minus Q2 plus Q3 plus Q5. Here, due to Q4 and minus Q6, the flux is not acting here. Similarly, another example we will see. Suppose, let us assume that here a Q charge is there. What is their charge? Q. Here, let us assume that one sphere is there. What is there? One sphere is there. Now, try to tell what is the flux in this sphere? 0. Even though here the charge is there outside, then we know the field lines are like this. That means what? Here the field lines are like this. Already we know, according to the definition of the flux, when the field lines are entered into the body, its flux is what? Negative. When they are leaving the body, its flux is what? Positive. That's why here this minus phi plus phi, total will become what? 0. That means here if any one enclosed body is there, within the enclosed body, if the charge is not there, then you may write Q in is equal to what? 0. That's why phi will become how much? 0. This is regarding Gauss law. What is the use of this Gauss law? Here, first what you should remember, by using the Gauss law, we are able to find out the expression for electric field. The expression for electric field. First, let us see some fluxes. Afterwards, we will move into electric field. Here, first I am taking, what is that one? 1 cube. What is that one? 1 cube. In this, the first application, this is very, very important. What is this one? Cube. Cube means we know. What is that one cube means? The cube means here all sides should be equal and that should be in 3-dimensional. That means we are considered this is the cube. Here, if cube is considered, then for cube, how many number of faces are there? Number of faces, how many? 6. Similarly, number of vertices, how many? Number of vertices, how many? 8. Similarly, number of edges, how many? Number of edges, how many? Here, sidewards, here how many edges are there? How many are there? 4. Here, 4. And here extra 2. Here extra 2. Total how many? 12. So, number of edges, 12. This is clear? If cube is given, then how many faces are there? 6. And how many vertices are there? 8. And how many edges are there? 12. Suppose I kept one charge Q inside the cube. That means here charge kept inside of cube. Inside of cube. If the charge is kept inside of cube, then try to tell what is the total flux, how much? According to Gauss law, what is the flux? 1 by epsilon naught into charge enclosed in it. That means how much? Q divided by epsilon naught. That means from this all surfaces, how much electric field lines are passing normal? Q by epsilon naught. Now, if you want to find out phi due to phase, how much? This total flux shared by how many phases? 6 phases. So, through each phase, how much? Phi total divided by what? Number of phases, 6. That is equal to how much? Q divided by 6 epsilon naught. Q divided by how much? 6 epsilon naught. Similarly, here I want to find out phi due to any vertex. Here this phi total shared by how many vertices? 8. So due to each vertex, what is the flux? Phi total divided by what? 8. That means what? Q by 8 epsilon naught. Q by 8 epsilon naught. Similarly, the total flux shared by how many edges? 12. So here phi due to each edge is equal to how much? Phi total divided by number of edges. That means what? Q by 12 epsilon naught. Like this we are able to find out. That means what? Here if any charge is given, first observe where is that charge. If the charge is at inside, then directly the total flux you may take phi total is equal to what? Q by epsilon naught. According to that, if they ask phi due to one phase, how many phases? Calculate. The total flux is shared by 6 phases. So due to each phase how much? Phi total divided by 6. Like that we are able to find out. Here the another one is, now also cube only I will take, but I will change the position of the charge. I will change the position of the charge. Here the next one is said to be, if charge is kept at center of phase, if the charge is kept at center of the phase, that means what? Like earlier, now also cube you consider. This is the, what is this one? Cube. Now here I kept a charge. Here I kept a charge. Now try to tell, we are able to apply Gauss law here. What is the Gauss law definition? The total flux is equal to the charge 1 by epsilon naught times of charge enclosed in the surface. Now this charge is within the cube? No. Where is the charge? At one face. That means we should consider another surface such that, observe carefully, we should consider another surface such that the charge comes to in the, what is that one? Cube. That means what? If you consider another cube, like this, if you, what is that one? Consider another cube like this. Now, how many cubes are there? 2 cubes are there. Now, where is the charge? At center. That's why now the flux is written as, here, what is that one? This charge comes to middle. Actually, if the charge is at center of the one cube, what is that one? Q by epsilon naught. This total flux is shared by how many cubes? 2 cubes. So now phi cube is equal Q by 2 epsilon naught. Phi flux is equal to what? Q by 2 epsilon naught. How 2 came? Here, earlier for Q charge, the total flux is shared by itself only. But now the Q charge flux is half passing through this cube and half passing through this cube. That means that is shared by 2 cubes. So we may write phi due to each cube is equal Q by 2 epsilon naught. Phi total how much? That is 2 into phi cube. Why? How many cubes are there? 2 cubes are there. So 2 into phi cube. That means what? 2 into Q by 2 epsilon naught. That is equal, again what? Q by epsilon naught. That means here total flux will not change. But here, instead of that, that flux is shared by how many cubes? 2 cubes. That's why due to each cube, what is the flux? Q by 2 epsilon naught. Total flux remains constant. That means the total flux is 2 into 5 cube. That means what? 2 into Q by 2 epsilon naught. So total again Q by epsilon naught. Total again Q by epsilon. Another example I will give, try to tell. Now also I am taking the same cube. I am taking the same cube. Here the charge is kept at vertex. Here, what is that one? Third case in the cube. If charge kept at vertex, charge kept at a vertex. So, here what is this one? This is considered as a cube. This is considered as a cube. Here I kept one charge at vertex. I kept one charge at vertex. So to come to center of this charge, how many cubes we should keep? 7 cubes we should keep. How? If you kept one cube like this, that means like this. Like this. What is that one? This comes to here. So here top another 2 we should keep. Total how many? 4. Similarly, these 4 are at front side. Back side how many cubes required? 4. Total 8. See carefully. Here if you are considered, this is the cube. This is the cube. Now we kept the charge here. We kept the charge here. So here to keep it at center, adjacent to this one cube required. Now also it is at top surface. So to bring that one into center, upside another 2. Totally how many we should keep now? 3. So even though now where is it? At edge. Even though now where is it? At edge. So to bring this one into center, this side how many cubes we should arrange? 4. Totally how many cubes will come? 8. That's why here the charge due to each cube, how much tell? Q by 8 epsilon naught. Flux will become, what is that one? Q by 8 epsilon naught. Yes or not? Why? Because here to bring, what is that one? To bring charge at center, 7 cubes we should join. 7 cubes we should join. Therefore, total number of cubes how many? Total number of cubes how many? 8. So each cube flux will become what? Q by 8 epsilon. Now we may write the phi total is equal, how many cubes are there? 8 cubes. So 8 into phi cube, that is equal to what? 8 into Q by 8 epsilon naught. So again total will become what? Q by epsilon naught. Total will not change. Total will not change. Now orally try to tell at suppose I am considering this is the cube. At edge I kept one charge. At edge I kept one charge. To bring this one into middle, here how many cubes required? 1. And above, here 1, here 1. Total how many required? 3. Total will become what? 4. So the flux due to each cube how much? q by 4 epsilon naught. Total flux, here don't confuse in between phi edge to charge kept at edge. If the charge is at center, what is the electric flux due to edge? Q by 12 epsilon naught. But charge is at center of the edge. Charge is at center of the edge. Now what is the flux due to each cube? Q by 4 epsilon. Difference understood? Here charge is at center of the cube. Then what is the total flux? Q by epsilon naught. What is the flux due to each face? Q by 6 epsilon naught. Flux due to each vertex? Q by 8 epsilon naught. Flux due to each edge? Q by 12 epsilon naught. That is, all those are applicable for if the charge is kept at center of the cube. If the charge is kept at center of the cube. Okay. Now, if the charge is kept at center of one face, to bring that one into center of the total system, how many additional cubes we should arrange? 1. So, flux due to each cube how much? Q by 2 epsilon naught. 2 cubes means 2 into Q by 2 epsilon, Q by epsilon total. Similarly, if the charge is kept at any one, what is that one next? Vertex. So, if the charge is kept at any one vertex, how many additional cubes are required to bring that one into center? 7 additional cubes. One is adjacent, 2 are 1 over the other, total 3, and backside 4. Total 7 additional required, already 1 is there, so 8. Now, if the charge is kept at any one, what is that one? Edge. Any one edge. So, to bring this one into center, here 1 cube required. Similarly, top also, another 2 required. Total how many additional? 3 cubes we should join. Total number of cube becomes 4. So, the flux due to each cube will become what? Q by 4 epsilon naught. Like that you should remember. Okay? So, like this we are able to apply for what is that one? Cube. Like that we are able to apply for cube. After knowing about this application, next we may move into general objects. General objects means what? Due to the charge distribution. Due to what is that one? Charge distribution. Generally, how many types of charge distributions are there? 3. One is, what is that one? Linear. Second one is said to be surface. And third one is said to be volume. Now, here, general process to find the electric field. To find electric field. Electric field intensity. Field intensity by Gauss law. By Gauss law. Generally, already you know how you find out the electric field intensity. How you find the electric field intensity generally? First we should calculate what? Coulomb's force. That force is divided with the charge, automatically you are able to get what? Electric field. This is another way to find the electric field intensity by Gauss law. Here already we know, according to Gauss law, what is the flux? Phi is equal to what? Q inside divided by epsilon. Already we know, according to Gauss law, phi is equal to what? Q in by epsilon. According to definition of flux, according to definition of electric flux, already we know electric flux. How you electric flux is defined? How the electric flux is defined? Electric flux is the integral of the scalar product of electric field and surface area. So here phi is equal, what is that one? Surface integral of scalar product of electric field and surface area. Already we know now. So the electric flux definition is what? The surface integral of scalar products of electric field intensity and what is that one? Surface area. Here these two equations are representing flux, so we may write therefore surface integral of E bar dot ds bar is equal to what? Q in by epsilon naught. By using this we are able to find out the electric field intensity. Generally any one object is given. Find out the electric field intensity by Gauss law. Means what you should take? First, by using flux definition, we should express the electric field intensity. Next, by using the Gauss law, we should express the electric flux and equate those. Here, suppose in this the case 1. First, I want to find out what is that one? Electric field intensity. Electric field intensity for a what is that one? Charged sphere or charged spherical shell. Charged spherical shell. I want to find out what is that one? The electric field intensity for a charged spherical shell. For a charged spherical shell. Here I am considering this is the spherical shell and this is the center. At center Q charge is there. At center how much charge is there? Q charge is there. This is spherical shell and at center how much charge is there? Q charge. I am considering its radius is R. Its radius is what? R. Now, by using the definition of flux, phi is equal to what? Surface integral of E bar dot ds bar. That is equal to what? Q in by epsilon naught. Yes or not? Here, according to the definition of electric flux, phi is equal to what? Surface integral E bar dot ds bar. And according to Gauss law, phi is equal to what? Q in by epsilon. Okay, now this one. Now, if you apply the scalar products, here, how you write scalar products? Surface integral of E into ds cos theta. That is equal to what? Q in by epsilon naught. Yes or not? A bar dot B bar. What is the formula? AB cos theta. So, this one. What is theta here? The angle subtended in between the electric field intensity and surface area vector. Already you know surface area vector. What is direction? Perpendicular to area. Length vector. What is the direction? Perpendicular to length. Area vector. What is the direction? Now, this is the charge. Where is the electric field at this point? Perpendicular. So, this is the E bar. And here I am considering this area is ds. That area is what? ds. What is the area vector in which direction? Perpendicular. Means this is the ds bar. So here electric field vector and area vector both are along. So here theta is equal to what? 0 degree. Theta 0 means cos 0 how much? So you may write this as surface integral of E ds is equal. How much charge is enclosed here? Q. So Q divided by what? Epsilon. Here, what is the constant? E. So E surface integral of ds is equal Q by epsilon. So E into, what is the surface integral of ds? If you add all small elements, you will get what? Total surface area. What is the total surface area? 4 pi r square is equal to what? Q by epsilon. So E is equal to what? E is equal to what? Q by 4 pi r square epsilon naught. We may write this as 1 by 4 pi epsilon naught into Q by r square, which formula already we know. So E is equal to what? Q by 4 pi r square epsilon naught means 1 by 4 pi epsilon naught Q by r square. This is the expression for electric field intensity. In beginning, how you find out this one? By using Coulomb's law, Q1 charge, Q0 1 charge. So force acting in between those two charges what? 1 by 4 pi epsilon naught Q1 Q2 means Q into Q0 by r square. F by Q0 is nothing but E. So E is equal to what we got? 1 by 4 pi epsilon to Q by r square. Here that is one method. This is another method by using Gauss law. Generally, if they ask derive the electric field intensity, means we should see. They mentioned Gauss law means we should derive like this. They not mentioned Gauss law means according to Coulomb's law we may find out. According to Coulomb's law we may find out. Okay. So this is one application. The another one is so what is the method? Okay na? Method what? Flux we should equate by using how many patterns? Two patterns. One is what? Surface integral of E bar dot ds bar. And second one is what? Gauss law. Okay. Second case I will take. What is that one? Case 2. Case 2. Electric field intensity. Electric field intensity. Intensity due to a charged wire, due to a charged thin wire. Here another case carefully. Electric field intensity due to a charged thin wire. Here I am considering this is a thin wire. What is this one? Thin wire. Here thin wire means it is having what? Certain charge. So here charge is there, the charge is occupied like this. Here charged wire means charge is only at one point or charge occupied about certain region. About certain region. What is the charge distribution? Linear charge distribution. So, according to what is that one? Definition of linear charge density. Linear charge density. Linear charge density denoted by what? Lambda is equal to what? Q by L. So, Q is equal to what? Lambda into L. If those are joined, then Q is equal to what you write? Lambda integral D. You may write like that. That is the charge. Now, if you want to apply Gauss law means what is the condition? Charge should be enclosed. Charge should be enclosed. Here enclosed? No. That's why to enclose this one, we should assume one surface that surface is said to be Gaussian surface. That surface is said to be what? Gaussian surface. What is meant by Gaussian surface? If the charge is not enclosed, then to enclose that one, we arrange additionally some surface. That surface is what? Gaussian surface. In our earlier cases, if the charge is kept center of one face of the cube, then how we arrange Gaussian surface? Another cube we arrange adjacent to it. Similarly, if the charge is at vertex, then how you arrange the Gaussian surface? By arranging another 7 additional cubes. Actually those are there? No. But we arrange. Why we arrange? For applying Gauss law. Gauss law is applicable if and only if the charge is at center. So this is, what is that one? Gaussian surface. Here what is the Gaussian surface here? Cylinder. Now I am considering the length of this Gaussian surface is L and this radius is considered as R. Gaussian surface length is what? L and radius is what? R. Now we are able to apply what is that one? Gauss law here. According to our application, what is the formula? Line integral, surface integral of E bar dot ds bar is equal, what is that one, right? Q in divided by epsilon. Okay now? Here, what is the electric field and area vector? How those two? Always perpendicular to each other. So you may write E surface integral ds is equal Q in. How you write Q in? Lambda integral dl divided by what is that one? Epsilon naught. You may write like this. So from this you may write E into what is the surface area of this cylinder? Surface area of this cylinder what? This is 2 pi r, this is L. So we may write E into 2 pi r into L, not pi r square. Okay, pi r square L volume. So E into 2 pi r into L, that is equal to, here lambda into integral dl. Integral dl means what? Right. Integral dl means what? L. Why? Charge is around about the length L. So lambda into L by epsilon naught. Is that right? Now what are cancelled? L, L. So E is equal to what? Lambda by 2 pi epsilon naught R. This is the expression for electric field. Okay. So what is the expression for electric field? E is equal lambda by 2 pi epsilon naught R. If you practice, the application is very, very easy. Here, what is that one first? Surface integral E bar dot ds bar is equal to what? Q in by epsilon naught. For any surface, here angle is what? 0. Angle is what? 0. If the charge is negative charge, then angle will become 180. Why? Negative charge means electric field is inside and this area vector outside. So 180. But for positive charge always 0. There is no any other possibility. So here what is that one? Cos 0, 1. So E surface integral ds, that is equal to Q in what? Lambda integral dl by epsilon r. These values you should take care, that's all. So E into surface integral of ds. So its area means what? length into breadth. Length what? L. Breadth means what? Circumference. So what is circumference? 2 pi r. So 2 pi r into L. That is equal lambda integral dl. Integral dl related to what? Charge. Charge where it is there? Along length. So integral dl means what? L. Suppose charge is like this. Integral dl 2 pi r. Charge is like this. Then integral dl what? 2 pi r. So like that. Here along length, so L. By simplifying that, E is equal to what? Lambda by 2 pi epsilon naught r. Like that, we may do some more applications tomorrow. Okay? Thank you.